Hello, I'm Bruce Yang, and today in Homemade Science I'd like to take a look at some of my marble tracks that I've built over the years. Now, I built these pieces as a way of introducing or reinforcing students' ideas on motion and acceleration, inertia, potential and kinetic energy. So let's take a quick look at some of them. This piece I refer to as a Galileo track. It starts at the same height on either side, but this side is 3 times longer than this side is. And so my first question would be, if I were to release the ball here, could it possibly roll off the opposite side? Well, let's give that a quick try. And we see it doesn't. How about if I try it from this side? And it won't do it from that side either. This piece was important because it was actually a piece that Galileo designed to help explain the idea of inertia. When looking at probabilities, here are 2 examples of prediction tracks. For example, will I get 1 million views for this video? Here are my choices. I'd say yes, it's possible, chances are slim, and no way. Well, I was hoping for better, but it looks like my chances are very slim. Now, this piece has 2 tracks that have identical curves, and as you can see on the side it says, which position gets the ball to the bottom the quickest? So for this piece, if we lift the balls to the same position and release them, we would expect them to get down to the bottom together. But what would happen if we put them at different positions? We find that position doesn't make a difference. If we release them at the same time, they will reach the bottom together. Now, I built this piece to help explain the behavior of pendulums in regards to a revelation that was made by Galileo. Now, here we have 2 pendulums that are the same length, and if I pull them back the same distance, well, they swing together. They have the same period. It takes the same amount of time for it to move back and forth for one movement. But Galileo showed that if I pulled them back different distances, they still have the same period, with the same amount of time for it to swing back and forth for one movement. Now, if I pull the apples back and release them at different times, we can hear them hit at different times. And if I pull them back together to the same distance and release them together, they hit together. Now let's try pulling them back different distances, but releasing them at the same time. Once again, we hear that they're hitting together. The same is what we find on these tracks. Now, I think one of my favorite pieces have been the high-low tracks. I have a number of them, and they start out very simple, something like this. And as you can see, there's 2 tracks. Both tracks start at the same height and end at the same height, but their path from one side to the other is completely different. This one is a straight path. It's the shortest distance between 2 points, whereas this track drops down to a lower level, covers a lot of distance, and then finally comes back up again at the very end. So the question is, which track would get a ball over to the opposite side the quickest? Well, I have 2 steel balls here. Let's give it a try. This track drops quite a bit lower, but we still see the same results. Same idea, only this time I've added a hump in the center here. Let's see what happens with this one. We have a track that has 2 humps. This track I used to help explain the behavior of pendulums. The tracks are the same length, but as you can see, the slope is much different from one to the next. The first track represents a pendulum that is 24 centimeters long, and it would have a period of 1 second. This track back here represents a pendulum that would be 99 centimeters long, and it would have a period of 2 seconds. And the third track back here, which is much gentler, represents a pendulum that is 222 centimeters long, and it would have a period of 3 seconds. So this helps to visualize why longer pendulums have a longer period. Now, if you want information on any of these pieces, I've made videos on all of them, and you can find a listing of them in the comments section below. As always, I'd like to thank you for watching, and go on to part 2. I'll show you some construction tips on how to build your own tracks, and I'll end up building a loop-de-loop track. Okay, bye!